First presentation will be given by Dr. Yuheng Zeng from Ningbo Institute of Material Technology, Engineering, the Chinese Academy of Science. He will talk about development of industrial high-efficiency TOPCon technologies. Dr. Zeng, the floor is yours.
Hello everybody. It's great to have my presentation in here. So I will share my PowerPoint. Can you see the PowerPoint?
Yes, if you just go into presentation mode, then everything's fine.
Okay. Let's begin. Okay, I'm glad to give my presentation here. My topic is about development of industrial TOPCon technology. And this is my contents. The first part, I will introduce our groups. And our group have 13 members focused on the PV research. Our group leader is Professor Jichun Ye. And our research includes silicon solar cells, perovskite, silicon tandem solar cells, and analyze group. And this is our representative works. The first one is we produce the high efficiency silicon and tandem cells. And the second one, we just developed the excellent passivation TOPCon, including the N-type TOPCon. And recently, we promote the IVOC to a high level, about 756 millivoltage. And the G0 is 0.7 VN. And also the P-type TOPCon, we use the PECVD loop and promote IVOC to 732 millivoltage. And the journal is about 4 to 6 VN. Also, we have published more than 30 journal papers. In the industrial research, we are the first group to develop the tube PECVD equipment since 2018. And also, we developed the 2-in-1 technology for the tube PECVD equipment. And the second part, I will introduce the development of TOPCon in industrial, especially in China. And TOPCon is the polysilicon passivating content. However, TOPCon is more popular in China, so I will name it TOPCon in my speech. And we can see it. TOPCon has been accepted in this year because these cells began to earn money. And the production efficiency grows very quickly, and it reached 24 to 25. The accumulated capacity has reached over 70 gigawatt, and also the orders grows very rapidly. And recently, it's over 100 gigawatt. It's a very quickly speech. And the champion efficiency also grows very quickly. And Jinko has reported their 26% TOPCon solar cells. And you can see the growth of the efficiency just come from the VOC. And the VOC has reached the level of 720 to 725. And this increasing of VOC just thanks to the boron emit. And The ball emit, the journal is as low as 10 VN. And I think the laser SE will further promote the growth of the efficiency. And the third part, I will introduce the technology moves for the TOPCon cells. We can see there are 3 loops for TOPCon: LPCVD, PECVD, and PVD. PVD just means the spot limit. And we can see the numbers of the process of these 3 loops is similar. However, the mechanism of the film's deposition are different in nature. First, we will introduce the LPCVD loop. As we know, this technology is the most mutual technology, and it has been developed by about 6 years. The advantage of this technology is it uses the excellent materials, including the thermal oxides and the blistering-free polysilicon. So if we use this, if we use thick wafers and SMBB technology, this technology loop starts to earn money if the per million is more than 0.05 IMB per watt. However, this technology has many shortcomings, including the first one is the low deposition rate. The second, it requires additional phosphorus doping. Third, it resists very serious waveform deposition. Fourth, because of the waveform deposition, the quasi tubes will be broken by the thick amorphous silicon films. So you need to replace the tubes every 2 to 3 months. So it costs a lot of money. Fifth, it's difficult to deposit different amorphous silicon. So the above shortcomings reduce the attractiveness of this route. However, people are always clever. Industrial people will always think the solutions to figure out the problems. The 2 key technology is the first one to develop the dual injection and the etchant technology. It will be very help to promote the capacity. The second one is to develop the coating technology to protect the tube, quasi tube, which can increase the life of the quasi tube. Some production, they say they can prolong the lifetime of the tube to more than 4.5 months or even to half of a year. And okay, the second loop is the PECVD loop. I think PECVD loop is expected to solve the above shortcoming of LPCVD. The advantage of this technology include the first one. The first one requires it have the high deposition rate. Also, it can't do the institute doping, and it's easy to introduce different doping elements. 3, it has very small waveform deposition. 4th, it has no amorphous silicon depositions on the quasi tube, so it can cut the production cost very significantly. So it will be very welcome for the industrials. Also, I think the PECVD is a route with better compatibilities. And we know the PECVD have 2 kinds of equipment. However, the industrials choose the tube 1 because it's cheaper than the plant PECVD. Okay, in the past several years, people think they were very challenged. There are 5 primary challenges for the PECVD technology. The first one is the conventional tube PECVD cannot deposit the amorphous silicon continuously and stably. Fortunately, this problem is solved by NIMTE and their partner in the past few years. The solution is we developed the anti-conductance designs of graphite boat, which help the PECVD deposition process stable. The second one is the PECVD amorphous silicon is easily to bristling during high temperature annealing. This problem can be solved by reduce the hydrogen concentration in the films and also reduce the strength in the films. And the third problem is in lack of 2-in-1 technology. And recently, we developed 2 kinds of 2-in-1 technology, including the plasma oxidation and the ozone gas oxidation. And in the practical, we found these 2 technologies can be used in mass production. And also, these 2 technologies can promote the efficiency of the cells more than 24.5%. And now, the tube PECVD is approaching matures. And recently, this technology is accepted rapidly by the industrials in the past 3 months. And the new increased order has been over 100 gigawatt. And also the efficiency of this technology has reached 25%. Finally, I will introduce the PVD move. The PVD move also developed in the past 3 years, and its champion efficiency also reached 26.1. This work comes from the Jollywood. And this technology, the advantage of this technology is there's no wraparound deposition, which helps improve the yields and also reduce the process. However, the primary shortcoming of this technology is it requires high investment. And also, the starting-up rate of the equipment is low. And also, the PVD bombardment will be very serious. Maybe it will not good for the preservation. Okay, finally comes to the summary. And I think the anti-TOPCon has been accepted by Chinese industrials, and the capacity is growing very quickly. At this stage, the 2-3 technology move will still in competition. And I think the tube PECVD will be better because it has better competitive and expandabilities. So we need to pay more attention to this technology. Okay, this is my speech. Thank you for your attention.
Okay, thank you very much for your presentation. Hello again. I just want to introduce myself. I'm Shravan from TaiyangNews. I'm the head of technology. So I'm taking over from Michael to moderate this session after his introduction. So, I have one question. So what is the actual efficiency delta between the PECVD and LPCVD and PVD? So can you say something over there?
Okay.
Exact efficiency.
Okay, okay, no problem. In my opinion, I think these 3 technologies can develop the same efficiency of TOPCon cells because the preservation quality is quite similar, and the bottleneck is in the front side, not in the rear side. So there's no initial difference for the efficiency. However, the difference is the cost. The cost is the decide which rule will be win. And in the three rules, I think PECVD will have the advantage to reduce the production loop. This is the most secret, the powerful. Yes, for this.
Okay,
technology.
so that means, do you think that PECVD is going to take over the market? Because anyway, PV is really. Yeah, please.
If we need to take this conclusion, I think it's a little too early, because this all technology is in competition. So I can say which one will become the successful or be the dominant recently. Maybe we'll fight after 1 year. Maybe it has a good conclusion.
Okay, so just in 1 or 2 sentences, what are the major problems with LPCVD? The top 2, PECVD, the top 2 issues.
Issues, I think the uniform of the oxide, I think is one problem. And others, I think the dust, maybe some problem will introduce infect the quality of the oxide. And I don't believe the blistering will be the problem. And I think no problem. This technology will approach mutual.
Okay, great. Yes. So thank you very much for really finishing your talk in the prescribed time. Thanks a lot.
Thank you. Thank you all. Bye-bye.
Bye-bye. And please stay in the chat room so that if there are any questions, you can also answer in the chat.